What's up, guys? And welcome back to the continuation of our discussion in Lesson 3, Parabolas. So for this video, we are going to discuss the standard forms of the parabola. Okay, so for the standard forms of a parabola, we have two general standard form. Okay, so we have this first here, the quantity of y minus k squared equals 4p times the quantity of x minus h. So this is when our opening is from the left or to the right, or in other words, the axis of symmetry is horizontal. And we have the second form. We have the quantity of x minus h squared equals 4p times the quantity of y minus k, where the opening is upward or downward, or meaning the axis of symmetry is vertical. Okay, so let's study first the first form. Okay, so we have this form, quantity of y minus k squared equals 4p times the quantity of x minus h. Okay, so we have these different elements. If you can remember, we have the different elements here. So first, we have the vertex. So it's very easy to find the vertex. It's just the h and k here. Okay, so take note that the form, the standard form, has the operation of subtraction. So minus. So whenever this is minus, our value is just value of h and k are positive. However, if this is plus, okay, so for example, if this is plus, what happens? So if it's plus, it is actually, remember, plus is actually negative times negative. Okay, negative times negative. So we have actually negative minus k. So whenever this is plus, your answer, the value of h and k, will be negative. For example, if this is plus k plus h, this is actually negative h and negative k. Okay, then we have the focal distance. Okay, so the focal distance here can be found in this part 4p. So if we're given a constant, we simply divided it by 4. For example, if the case here is 12 or 8, okay, just divide 4, and whatever is the answer, that is the focal distance. So if it's 8, so 8 divided by 4, the focal distance is 2. Okay, then next we have the direction. Okay, so the direction, we must take note the sign of the constant here. Okay, sign of the constant here. So whenever that part there is negative, okay, the direction is, or the opening of the parabola is to the left. Whenever the P is positive, okay, so the direction or the opening of the parabola is to the right. So you can observe now that if this is the scenario here, okay, the quantity of y minus k squared, 4p, quantity of x minus h. Okay, if that is the scenario, so let's try to erase it. We will realize that the axis of symmetry is horizontal. And again, if it's horizontal, axis of symmetry, we actually have y equals k. Okay, so for axis of symmetry. And for the directrix, it's vertical. Okay, so how do we know? By looking at the given, how do we know that it is a horizontal or left to or right direction? Okay, so shortcut, just look at this part here. Okay, so the term, or yes, the term that contains the power 1. So in this scenario, power 1, not to the power of 2 or squared. Okay, this determines our axis. Okay, since the power here is 1, if the squared is this part here, okay, so ang squared is this, y. Hence, this part here is x to the minus h is just to the power of 1. It means that the axis of symmetry is horizontal. Okay, and hence the axis of symmetry is y equals k. Okay, so next for the focus, so since it's horizontal, axis of symmetry is horizontal, we will add the focal distance at h, because remember h is the horizontal movement. So plus, we use plus p if it's opening to the right, and minus p if it's opening to the left. So for example, here in this image, so this is our vertex hk. Our hk is 0, 0. Okay, h is 0. Here is h. K is also 0. Okay, so we add, since it's opening to the right, okay, opening to the right, and our p here is assumed to be positive. Okay, so here p is positive, p is greater than 0. So we add p plus. Okay, if it's opening to the left, minus p. Okay, now the directrix. So okay, again, the directrix, since the axis of symmetry is horizontal, hence the directrix is vertical. Take note that these two here are always perpendicular to each other. Okay, so we have x equals h. So if it's plus here, take note, if the focus is plus, directrix is minus. If the focus is minus, the directrix is plus. Okay, so focus and the directrix are opposites also. Okay, then we have the length of the latus rectum. So the length of the latus rectum is simply this, 4p, but the absolute value. Okay, okay, so let's look at the second form. So we have the quantity of x minus h squared equals 4p times y minus k. Okay, so of course, if the first form, the axis of symmetry is horizontal, it's facing left and right, or right, sorry. Now, for the second form, it's vertical. The axis of symmetry is vertical. Okay, so it's actually up or down. So we don't need to trouble with vertex again. It's similar. Just find the h and k. Okay, the focal distance, just divide by 4. Okay, direction. Okay, now, so for the direction, if p is negative, okay, so the value of the constant here is negative, of course, then obviously the direction is downwards. If p is positive, the direction is upward. Okay, now for the axis of symmetry, it's vertical. Okay, so you might be confused about this because we said vertical, but the equation is x equals h. So why is it x equals h? Okay, so remember, when we talk about vertical lines, it is always passing through the x-axis. If we talk about horizontal lines, it always passes through the y-axis. So that's why if it's vertical, it's x equals, and of course the horizontal movement is h. So while the other one, so here in our first form, y equals k, it's horizontal because it passes through the y-axis. Horizontal, it passes through the y-axis. It passes through the y-axis. Okay, so now for the focus, since it's vertical, up and down, hence we add at the vertical movement, which is k. So we add the focal distance, p. So plus if it's upwards, and minus if it's downwards. So plus p if the parabola is opening upward, minus p if it's opening downwards. Now for the directrix is opposite always from the focus. So if it's plus for focus, the directrix, you can find the directrix by subtracting p from the subtracting p from k. Okay, so this is the form of our directrix. Again, since it's horizontal, it passes through the y-axis. Okay, and it's paired with k because y-axis, y, k. So minus P if it's plus for the focus, plus P if it's minus for the focus. And of course, the length of the latus rectum is just 4P. So this is our, we can just get the absolute value of this here. That's the length of the latus rectum. And that's it for the explanation for the standard forms of parabola. In the next videos, we'll be having an example to show you how to solve and graph a parabola. See you there.